Hello everyone, today we make a new video of our assignment 5, and that the process of encoding and decoding using base 64 and XOR encryption. uh, in this process we are demonstrated the process of encoding, XOR encryption, key generation and decryption of a flag, and we actually find out the flag which is hide in our encrypted code. Before starting the video, here we have two file. uh, the code of the file is here, the imported base 64 file, and the output value. There are some output value here, and the encrypted code here. uh, in this process we find out the flag. the Here we are imported base 64, and the base 64 encoding ensured that the flag and the key are printable and easily transferable format. So uh, so the imported base 64 module which will be used to encoded the flag and key into the base 64 format. And here we have a flag bracu redact the string format. uh, the flag is set to the bracu redact, which is represent the flag. The actual content is hidden here. uh, the key also here, the which is encryption key for the XOR operation. The actually key content is hidden here, and we have a flag and key encoded into the byte using the encode, then base 64 encoded using the base 64 encoded. Here we return the result of base 64 encoded is then decoded back to the using decode here. So let's write the code and find the flag in this process. So we again import. So here we again import the base 64, import base 64 here. uh, the next line we initialize the flag name. So we start the initial partial flag and write it, so that we write initial flag. We see there are the flag name, so we write it here, bracu and initial is the encoded flag. We write here the base 64 encoded function, uh, the string format, so that base 64, which is a binary to text encoding. So we write it here, base 64 dot b64 encode initial flag dot encode decode. Sorry. Now we printed here the encoded flag. So we print base 64. In here the output show the base 64 encoded version of BRAQ. So we run it. Now we define the XOR operation. So here we call the function def XOR operation and define the variable num, and in this function we operation between a number and a character ORD converted a character into the ASCII value. So ORD CHR converted it to ASCII value num and return CHR to the result. In here, the XOR operation is applied between the ASCII value of the character and the given number. The result is then converted back into the character of using CHR. This XOR function is essential for both the key generation and the description process. So now we generate the key. So here we again call the function generated key generated and encoded flag encoded flag. We now define our output value here. So the variable is data array and we copy the value here and paste it. And this data array is contain a series number of that are used in the XOR operation to generate a key. And now the XOR result are concatenate into the key string. So we define it key string and index is initially 0. Now we make it loop flag and write it to index, and initialize increment the value 1 and return it. We reverse the key, so we return it key -1. Now we derive the key, so we call the generated key function and passing the base64 encoded flag to generate the decryption key. The recovery key is printed out the debugging process. The key will be used in the decryption process. So we call it decryption and print it. Print, name it to recovery key. Decryption key. Now we call a function of decryption flag. Now we call a function for the decryption of flag. So we call the function here def decryption decryption flag decryption flag 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 and decryption key decryption key define a data array. In that function, decryption of the flag using the derived decryption key and the data array. The decryption flag is initialized as an empty list which will hold the decryption character. The loop process each pair of element from data array is using the key. The character are XOR read to decryption the flag. The key is actually reverse the particle. The key is actually the reverse the key index and track the position of the key. After processing all pairs, the decryption flag list is joined into the string and return it. So we just write here decryption key process decryption flag into len flag length key underscore index equals to 0 initialize key underscore length equals to len decryption key and initialize the I value 0. In this process we make a loop I is less than of flag length flag length uh, we already write it, so just paste here. and finally we call the function here, final decrypted flag. We pass the decrypted key and the data array into the decrypted flag function into the decrypted flag. After decrypting, we reverse the final decryption flag and base64 decoded it to the retrieve the original flag. So we call the all the function here, decrypted flag, key here. So final decoded flag base 64. We call it again, so we write it again, base 64 decode final decrypted flag, and we march it to reverse it so that we write this -1 and decode write it final, and print it. flag, so we write it decoded flag. Final decoded flag. Final decoded. Final. Just final. Coded. Decoded flag. Now we run it. There are some errors, so we find it to solve it. Just a minute. Here are the errors in code. Again, ORD. Line 14. Decoded flag. Decryption flag. So here write it. So DECRYCRYP decrypt flag. Decrypt. There's some problem here, so we just remove and copy paste here. Now run it. Here are the decoded flag we find. There are some mistake here, so we just copy and paste the code. So that's it. That's the flag here we find.